Hi everyone, this video is for section 6.4, simplifying complex fractions. What I want us to note here is that this particular problem has a little bit of a twist to it. Notice that the exponents that we have here are negative. So it's actually kind of compressing the problem a little bit, and it might kind of trick the eye. What I also want to note here is remember to not make that common error of reducing by terms. So you don't want to look at this and say, oh, there's an n raised to the negative 1 in the numerator and an n raised to the negative 1 in the denominator, so I can cancel it. Remember, we can only reduce by factors. We cannot rip out items by term. So I did want to touch on that. Okay. So to begin, let's go ahead and rewrite this problem so that we can actually see what we need to do. My numerator, instead of m raised to the negative 1, I'm going to rewrite that. Remember, if m is unhappy upstairs, we're going to move m downstairs. And then we do have our plus 2 to the n. And again, just so I can see everything written as a fraction, I'm going to put that over 1 for now. Now I'm going to move to the downstairs, or to the denominator here. And again, m raised to the negative 1 is unhappy, so we are going to move m downstairs, and this is minus n over 1. I wanted to do this so that I can clearly see the denominators for my complex fractions, or for my rational expressions in my complex fraction. That is the more appropriate way to say that. So what I'm going to do now is I'm going to rewrite the problem here with just a little bit more space. So nothing else is changing other than that I'm spacing some stuff out so that I can comfortably put work in without it kind of being written on top of each other. So what I want to do here is I want to focus on finding a common denominator amongst all the denominators in the complex fraction. So I know that I have a denominator of m, of 1, of m, and 1. So I would say in this case, would you agree that our least common denominator here is just going to be m? So for our first term, it already met our goal. We have a denominator of m there. For our second term in the numerator, I'm going to have to multiply both the top and the bottom by an m. Again, we do that because we want to make sure that we're not changing the value of the rational expression. We just want to make it fit so that it has the denominator that we desire. Again, when we move down to the denominator of the complex fraction, that 1 over m, it's met our goal. And we're going to need to multiply by m over m in order to make it fit for our second term. So if we were to go ahead and clean this up, we should now see that we do have a common denominator here, so I'm going to write this all over m, so I'm just going to use my shorthand. I'm going to have 1 plus 2mn. I just chose to write it alphabetically because that's just my preference. If you had written 2 times n times m, that's perfectly fine. Now what I'm going to do is I'm going to put my other division bar in, and I'm going to clean up my denominator here. So this is going to be, it's going to have the same value, same denominator of m, and this is going to give me 1 minus n times, actually, I'm going to, again, do that alphabetically, so m times n. All right? So again, we can kind of use a shortcut here. What I'm saying is, notice that the denominator in the top portion of your complex fraction has a denominator of m, and the bottom of your complex fraction also has a denominator of m. This is not coincidence, this is actually strategy. That's why we made sure that our denominators, no matter where they were on the complex fraction, all matched. I can simply go ahead and cross them out. They're going to reduce out. And if you haven't seen the other video, the reason being is the following. So I have 1 plus 2 times m times n all over m. And that division bar is technically the operation of division, so I'm just going to write that, followed by 1 minus m times n all over m. So if you recall your previous knowledge about division of fractions, we can skip the first fraction, so we can just write it as we see it. we can flip or take the reciprocal of the second fraction, and that's going to give us a multiplication to work with. Okay, hopefully I'm doing all right. So what this is going to do is, it's going to do just like I said in the shortcut, is that the m's are going to cancel because now there is one in a numerator position and there's another one in the denominator position. Let me move this up so I have a little bit more room. And we're basically left with the following. We're going to be left with 1 plus 2 times m times n all over 1 minus m times n. If you notice, this answer here, there's nothing for us to factor out, or there's nothing for us to reduce. Remember, we cannot reduce by terms. We can only reduce by factors. So if I wanted to reduce a 1 plus 2 times m times n, there needs to be a 1 plus 2 times m times n in the denominator. In this case, we don't have that. So we're just going to leave the answer that we have circled in orange. I hope this was helpful. If you do have any other questions, please let me know.